All right, so in today's video, I wanted to go over inverse functions and tie that into inverse relations. So under notation here, whenever they want you to find the inverse of a relation, they label R. Notation-wise, we'll label the inverse of this relation as R, but we'll have a -1 as sort of like a power. But this -1 is denoting the inverse notation. So in order to find the inverse of a relation, please remember a relation is really just a set of points, x comma y. In order to find the inverse of a relation, all we have to do is switch the x and y values that we are given. And we'll go over a specific example in just a moment. And tying into this, there is also a one-to-one relationship that we have to consider when we're dealing with inverse relations or functions. In order to be one-to-one, a function has a one-to-one relationship if the relation R, and that's key right there, and its inverse are functions. So we'll look at that in just a moment. Knowing whether or not a function is one-to-one is also a skill they want you to learn in this class. So if we look at the examples here, we're given a relation. We have that curly bracket notation with a set of points, x comma y. In order to find the inverse of our relation, all we have to do is switch the x and the y's. So here I'm going to start off with that curly bracket notation. And for this first set of points, I'm just going to switch the x and the y. I'm going to go ahead and do that for all the other ones as well. But 4 comma 2, -1 3, and -2 comma 4. Don't forget the curly bracket notation at the end. This right here is how we find the inverse of a relation. Once again, all we did was switch the x and the y values. And then we ask ourselves the following question: is R a function? Yes or no? If you look at R right here, none of the x values are repeating. So for the relation R, yes, it is a function. Now the question on this middle part right here is asking, is the inverse of R a function? If we look at the inverse of R at the x values, we notice that -2 is repeating for the inverse of R. In this case, the inverse will not be a function. So write no. So because R is a function, but our inverse is not a function, R as a whole will not be one-to-one. So this would be no. In order to be one-to-one, your relation has to be a function and the inverse has to also be a function at the same time. So look at another example right here. Let's look at example number 2. They give you a relation, a set of points. They want you to find the inverse of that relation. So I'm going to start off with the curly bracket notation. I'm going to switch the x and the y values that were given. Don't forget the curly bracket notation. And then now we ask ourselves the same questions we asked in the previous example. Is R a function? Yes or no? If you look at R, the x values, the 1 right here will be repeating. So because of that, R will not be a function. If you look at the inverse of R, the specific x values are here. Notice that they're all unique x values. None of them repeat. So we'll say that the inverse of our relation is yes, it is a function. Now as a whole, is our relation 1 to 1? Well, we have to consider these other two factors right here. We said that r is not a function, yet the inverse is a function. In order to be 1 to 1, once again, both of these have to be yes. So in this case, r would not be 1 to 1. All right, and the same can be said for a mapping diagram as well. Here we can also map out r based on this diagram. So for our first point, 0 will map to 6. So 0, comma 6. 1 will map to 2. 11 will map to 6. And that is pretty much it. They included this 8 here just to kind of distract you, but this is our relation right here. In order to find the inverse of our relation, once again, we're going to go ahead and switch the x and the y coordinates of what we're given here. So I'm going to switch the x and the y values. Don't forget the curly bracket notation. And then once again, we ask ourselves, is our relation r a function? If you look at r right here, none of these are repeating. None of the x values are repeating. So yes, r is a function. The next one we'll say is the inverse of function. If you look at the inverse of r right here, we do have repeating x values right there. So we'll say that the inverse of r is not a function. And then is r 1 to 1? Based on these two above, we can say that no, r is not 1 to 1. Both of these have to be yes. The relation has to be a function. At the same time, the inverse has to be a function. All right, so that is when you're given a relation. All right, and similar to the vertical line test, when we use that to determine whether a relation was a function or not, there is also a horizontal line test that we'll use to help us out in this next section. The horizontal line test will determine whether or not the inverse of a relation is a function. And if you look at this bullet point right here, both the relation and its inverse must be a function in order to be a one-to-one function. And that's exactly what we had covered up here. In order to be one-to-one, our relation has to be a function and the inverse as well. But now here, they want you to think about this graphically using the vertical line test and the horizontal line test. So let's look at these two examples right here. If you look at this example right here, once again, we're given a function. Let's just say I call that r. In order to determine whether this is a function, I will use the vertical line test. If I use the vertical line test, no matter where I place this, I'll only intersect the black line at one point. So here, we'll say that r is yes, it is a function. If we think about the inverse of r, the inverse of this function, in order to determine if the inverse of this graph is a function, we have to use the horizontal line test. In order to use the horizontal line test, I'm going to go ahead and draw a horizontal line now. And notice here, when I draw in this horizontal line test, I only hit it at one point. If I continue to move this horizontal line horizontally, around this graph, notice that I'll always only hit 1 point on that black line. So because I only hit 1 point, it passes the horizontal line test. Therefore, we'll say that the inverse of this graph is a function. So I'm going to put yes. And in order to determine whether this graph is 1-to-1, both our graph has to be a function and the inverse has to be a function. And because these match, we can say that overall this graph is yes, 1-to-1. So once again here, just to be clear, in order to determine whether the graph itself is a function, we use the vertical line test first. And then we use the horizontal line test to determine whether the inverse of this graph is a function. We'll go over one more example here, number 5. We'll apply the same concept. We'll call this graph R again. So if I'm dealing with R, in order to determine if this graph is a function, I'm going to apply the vertical line test. I'll always only hit 1 point. So because of that, we'll say that this graph is, yes, a function. Now we got to deal with the inverse of this graph as a whole. In order to determine if the inverse is a function, we use the horizontal line test. If you apply the horizontal line test here to this graph specifically, notice here that we cross multiple points horizontally. So because of that, we'll say that the inverse of this graph is not a function. So as a whole, is this graph 1-to-1? Because the inverse is not a function, we'll say that no, this graph is not 1-to-1. So these are ideas I want you to be thinking about in terms of inverse functions. Here, once again, the most important idea is that the inverse is switching the x and y values. We'll talk more about that very soon. And then applying the horizontal line test to determine if the inverse is a function. And that's pretty much it for today. I hope you have a great rest of the day.